System of linear equations in two variables. A system of linear equations consists of two or more linear equations. A solution of a system of two equations in two variables is an ordered pair that makes both equations true. We have three types of systems of linear equations. We have a consistent system which has one solution. The type of lines will intersect. We have an inconsistent system which has no solution, doesn't have a solution. Those would be parallel lines. And then we have a dependent system, which has infinite number of solutions. The type of lines, identical lines. So as we look at solving system of linear equations in two variables, there are three ways that we're going to find or be able to find the solution or solutions. And that the first way would be by graphing. The second way by the substitution method. And the third way by the elimination method. So we're going to go over in this chapter or section each type of the different methods that we're going to use to solve systems of linear equations in two variables. So our first way we're going to look at is graphing. To solve a system of linear equations by graphing, number one, we're going to graph both linear equations on the same set of axes. Then number two, observe the point of intersection if there is one. And then we're going to determine, okay, if it intersects, it has one solution. If they're parallel lines, no solution. If they're identical lines, we have infinite number of solutions. So let's take a look at this example that we have that I'm going to write. We have x minus y is equal to 3, our first equation. And our second equation we have here, let's see. Let's make this three a 2. X minus y is equal to 2, and then we have x plus 3y is equal to 6. So we're going to graph. So before we graph, let's go ahead and let's label each line. We're going to label the first equation and call it L sub 1, line 1. And let's go ahead and convert x minus y equals to 2 into slope-intercept form. So we're going to subtract x to both sides. We have negative y is equal to negative x plus 2. Then we're going to divide by negative 1. And we have y is equal to x minus 2. Therefore, we have a slope of 1. And we have a y-intercept that starts at 0, negative 2. Our second equation, x plus 3y is equal to 6. We're going to solve this equation and write it in slope-intercept form. So we're going to subtract x again here. We have 3y is equal to negative x plus 6. Then we're going to divide by 3. And we have y is equal to negative 1 over 3x plus 2. Our slope is negative 1/3. Our y-intercept is at 0, 2. So we're going to graph each equation. Let's look at the first line. We're going to start at 0, negative 2. From there, we're going to find our second point using the slope. We go up 1 and over, up 1 and over. Okay. Now I found an additional point. That's okay. We can go ahead. We can do that. And if you want to, we can go in the opposite direction. We can go down 1 and over to the left. Connect the points. And we're going to label the line as L sub 1, or you can write the equation if you choose to. Our second line, we start at 0, 2. From there, our slope is negative, we're going to rise, well, negative 1, go down 1 unit, and then we're going to run over 3 spaces. So let's go. Go down 1 and over 3 spaces. 1, 2, 3. You can see right now where it is going to intersect. Let's do this again, slope. Go down 1 and over 3. 1, 2, 3. Connect your point. Connect the points. Here's line 2. So now you should be able to see the point where the two lines intersect. So we have a consistent system. That has one solution. And that solution is 3, 1.